Ladies and gentlemen, please be seated. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. Yang berbahagia Profesor Teknologis Dr. Muhammad Iqbal Saripan, Deputy Vice Chancellor Academic and International Universiti Putra Malaysia. Yang berbahagia Profesor Dr. Zulkifli Idrus, Deputy Vice Chancellor Research and Innovation Universiti Putra Malaysia. Yang berbahagia Profesor Dr. Ahmad Zaharin Aris, Dean Faculty of Environmental Studies Universiti Putra Malaysia, Principal Officer Tan Sri Dato', Datin, and honorable guests. Welcome to Inaugural Lecture, Invisible Water Treats Profiling the Environmental Pollutants by Yang berbahagia Profesor Dr. Ahmad Zaharin Aris. To seek blessing for today's event, I would like to call upon Ustaz Muhammad Farouk Nukman Zamri for doa recitation.
الفاتحة. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. بسم الله الرحمن الرحيم. الحمد لله الذي أوضح لنا سبيل الهدى والرشاد وجعل في اتباعه السلامة من الآفات والمهلكات والصلاة والسلام على سيدنا محمد المبعوث إلينا وعلى آله الطاهرين وأصحابه المجاهدين المخلصين ومن اهتدى بهديهم إلى يوم الدين. Ya Allah, Ya Rahim, praise be to God, the Lord of the worlds. Peace and blessings be upon our Prophet Muhammad sallallahu alaihi wasallam and his companions, and for those who followed his example till Judgment Day. Ya Allah, Ya Fa'alu lima yurid, we express our gratitude to you for allowing us to attend inaugural lecture on this auspicious morning. Ya Allah, we seek your blessings for a flawless progress of this event from the beginning till the end. Ya Latif, Ya Rahman, please bless us with your tawfiq and hidayah. Please guide Universiti Putra Malaysia to greatness, peace, glory and prosperity. Granted us with valuable knowledge that will be beneficial to mankind in order to gain your maradatillah. Ya Munzil al-Barakat, bestow peace to our beloved country Malaysia. Preserve us from any threat and disaster, neither man-made nor natural disaster. And to you, Allah, we ask for security and prosperity upon us, our leaders and our country. Ya Allah, please accept our deeds and please forgive us for our wrongdoing. ربنا ظلمنا أنفسنا وإن لم تغفر لنا وترحمنا لنكونن من الخاسرين. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وبارك وسلم. والحمد لله رب العالمين.
Thank you, Ustaz Muhammad Farouk Nukman Zamri. Ladies and gentlemen, I would like to call upon Yang berbahagia Profesor Teknologis Dr. Muhammad Iqbal Saripan, Deputy Vice Chancellor Academic and International, to chair the inaugural lecture and to introduce the speaker for today's inaugural lecture. Please welcome Yang berbahagia Profesor Dr. Muhammad Iqbal Saripan.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. And very good morning everybody. Yang bahagia Profesor Dr. Zulkifli Idrus, Deputy Vice Chancellor Research and Innovation, Universiti Putra Malaysia. Yang bahagia Profesor Dr. Ahmad Zaharin Aris, Dean Faculty of Environmental Studies, who's also going to present his inaugural lecture today. Associate Professor Dr. Muhammad Firuz Ramli, Deputy Dean, Graduate and Research, Faculty of Environmental Studies, Senior Officers of UPM, Management Members of Faculty of Environmental Studies, invited guests from other universities, industries and agencies, family members of the inaugural speaker, UPM staff and students, ladies and gentlemen. I see quite a packed hall today, which is very good. First of all, I would like to convey regards from Yang Bahagia Datin Paduka Prof. Dr. Aini Idris, our Vice Chancellor, who's not been able with us today because of prior engagement that she has. And I'm honored to be the person who's going to introduce Professor Dr. Ahmad Zaharin Aris in this auspicious occasion. Prof. Zaharin obtained his Bachelor of Science in Environmental Science and PhD in the field of Environmental Science, specializing in the field of hydrochemistry from University Malaysia Sabah, UMS. And he received that at the age of 25, and he became the youngest PhD recipient at UMS so far. And I think still the youngest, or maybe among the youngest in Malaysia. Prof. Zaharin was appointed as a tutor in 2007, senior lecturer from 2009 to 2013, associate professor until 2016, and he was appointed PhD, professor afterwards at the age of 33, specializing in the fields of hydrochemistry, geochemistry, environmental chemistry, and analysis and environmental forensics. He emerged as a strong, innovative university leader, where he has been appointed as the Dean of Faculty of Environmental Studies from 2016 to 2019. And prior to the present appointment, he was the Deputy Dean of the Graduate Research and Development from 2014 to 2016, as well as the Head of Environmental Forensics Research Center, ENFORCE, from 2011 to 2014. He also held many other chairmanships and committee memberships for various committees at the university as well as national level, and played a key role in establishing the environmental forensics context and accelerates the research and policy strategies that now have become parts of the Malaysian Transformation Plan. As an academic staff, he has been actively teaching in various courses in the environmental science and technology at both undergraduate and postgraduate levels. His involvement and contribution have helped to develop curriculum for environmental science and technology discipline in UPM, and also for several public and private universities in the country. He has supervised more than 70 masters by coursework students and PhD, and 4 postdocs, and 50 of whom are local students and 15 are international students. And under his supervision, he has also 14 PhD students, whereby 6 as chairman, and 29 masters, including masters by coursework students, whereby 6 as chairman, and 23 of them are from masters by coursework, and they are all been successfully graduated. On top of that, 35 bachelor students have been successfully completed their final year projects. In addition to that, he also has been appointed as internal and external examiners for masters and PhD thesis locally as well as internationally, including from UKM, UMS, UITM, University of South Australia, Vellore Institute of Technology India, Bharatiya University India, PSGR Krishmanal College for Women in India. Prof. Zaharin has received more than 1.2 million USD research fund from more than 50 projects from various agencies locally and internationally, where as a principal investigators, he has completed 26 projects, 7 international and 19 national grants with more than 500,000 USD value. Prof. Zaharin is the youngest faculty member with a brilliant academic record, including 300 academic writings related to his field in referred international journals, books, chapter in books, and the rest are conference papers, as well as 3 policy papers with over 2,200 citations in Scopus and 3,800 citations in Google Scholar. His current H index is 23 in Scopus and 32 in Google Scholar. Over 50% of his published papers are in Q1 and Q2 tiers. Few of his papers rank as the most downloaded papers and receive many citations within a short period of time. The Elsevier has ranked him third among the list of global experts under the category of distinguished competency of water quality, sediment and pollution. Together with his colleagues, he successfully has filed 2 patent applications on water filter paper and method of preparing biosorbent and biosolvent for removal of endocrine disrupting compounds and heavy metals. Quite a long title. One industrial design copyright on water filter and 1 copyright on emerging pollutants risk survey. Prof. Zaharin has received or has been awarded with many prestigious awards nationally as well as internationally. In the recognition of his academic and leadership capabilities, he was awarded with Excellent Service Award and Certificate of Excellence, Publication Incentive Award, more than 15 travel grant awards as keynote speakers, internationally as well as nationally. He appeared in few newspapers headlines as the youngest PhD recipient in 2009 and appeared in Malaysia Who's Who, Constitution, Government and Politics in 2013-14 edition. He has been featured in more than 20 appearances in TV, newspaper and magazine for his expertise, especially on water security and environmental forensics. Prof. Zaharin was also awarded with a prestigious award by UPM as Young Scientist Award 2013, as well as Vice Chancellor Fellowship Award, and nominated for twice Earth Sciences Prize 2015 and Any Prize Protection of the Environment 2015. He is known to be the youngest Syarahan professorial chair grantees. He's also the finalist, first runner-up for 2016 National Young Scientist Award by the Ministry of Science, Technology and Innovation. And he also has received the Golden Globe Tiger Award in 2017. Recently, he received Malaysia's top recognition as a Top Research Scientist Malaysia, TRSM 2018, in recognition to his contribution and achievements in the field of environmental chemistry and analysis by the Academy of Sciences Malaysia. He's also the finalist for Zayed International Prize, Young Scientist Award for Environmental Sustainability, and being the national representative for APEC Science Prize for Innovation, Research and Education, Aspire. Prof. Zaharin has been appointed as editor and editorial board for a number of scientific journals such as Nature Publishing Group, Springer, Elsevier Springer Plus Journal, associate editor for International Journal for Sediment Research, Elsevier, Environment Asia, World Applied Sciences Journal, and few others, as written in the inaugural book. He has been appointed also as the International Scientific Committee member for few international conferences and was the founding chairman of the International Conference on Environmental Forensics 2013. He has been invited to give numerous talks and tutorials and being consultants to many organizations in his field of research locally as well as internationally. To date, he has delivered more than 50 lectures and talks as invited speaker, plenary speaker, and keynote speaker in various occasions locally as well as internationally, including many talks and engagement with public and school children. So far, he has engaged and interacted with more than 5,000 audience. Ladies and gentlemen, it is no doubt that Yang Bahagia Prof. Dr. Ahmad Zaharin Aris has achieved excellence in academic and research as well as his professional involvement as written in the inaugural book. Indeed, this is an extraordinary accomplishment by a young academic as well as a scientist. Without further delay, let us now listen to Yang Bahagia Prof. Dr. Ahmad Zaharin Aris inaugural lecture entitled Invisible Water Threats, Profiling the Environmental Pollutants.
Bismillahirrahmanirrahim. I'm very honored for the introduction by the Yang Bahagia Professor at the NCA. So I'm here today to talk about the water threat especially about the invisible profiling and also how those water can significantly affect the human health. As a hydrochemist, I believe that we have a different view, especially when we talk about the water. Most of us believe that the water that we drink today is actually very clean, but somehow, of course, when we talk about the quality and also the content of the water itself, it might be very difficult for us to come up with the right definitions of the water quality itself. Most of us believe that when the water have no any taste, no any colors, no any smell, then the water itself might be very clean. So somehow, the one that we should always look into is actually the invisible threat that we have in our water. With the current situation all around the world, while from our understanding itself, we are actually having lack access to the water. As you can see from the United Nations statistic given in the slides here, 3 out of the 10 people all around the world is actually having lack access to the clean water. And we are in Malaysia is actually very lucky because we are being surrounded with many water bodies that somehow can help us to get good and also fresh water supply. So I'm here today to talk about the invisible water threat, profiling the environmental pollutants in our environment, especially the water. Thank you. Yang berbahagia Profesor TNCA, Profesor Dr. Muhammad Iqbal Saripan, Yang berbahagia Profesor Dr. Zulkifli Idrus, Deputy Vice Chancellor on Research and also Innovation, the Deputy Dean for Research and also Innovation at the Faculty of Environmental Studies, Associate Professor Dr. Muhammad Fiuz Ramli, my beloved parents, wife, and also family members, as well as the audience. And thank you for your attendance today to listen some of the sharing sessions about the invisible water threat on the pollutants. So, ladies and gentlemen, so this is what I'm going to cover. Basically, the introduction will cover about the current status of the water pollutants and also what we need to know about the water itself. And of course, I'm going to talk about the emerging contaminants, past and also new, as well as the present research orientation on what are the focus that we are looking at, especially when we are dealing with the water research. And after that, I'm going to look into the sources and also pathway of the contaminants in the ecosystem, as well as the from ecosystem to human, what we drink, what we eat, and what we inhale in our body. Then, I'm going to look into the effect of the ecosystem and also human, seen and also unseen. So this is something that are very worrying because if you can see something, then we can just somehow eliminate those. But the most important thing that we need to look into things are something that we cannot see. And of course, the conclusion and also the way forward, how we should manage the water and also what are the mitigation measures that we should have in order for us to have good water supply for human needs and so on. So for the basic introduction, as we can see here, there are about 7.7 billion people that we have in 2019. And with that current number of people that we have, you can see that the population is actually growing the demand of the water supply. And with the current populations that we have, the extent number of the people living in the earth is actually coming decade is actually uncertain, where the numbers of people might be up and down, but somehow we can see that the reproductive statistic showing an increasing trend over the years. And of course, we can see that the world population is expected to increase by 2 billion of people in the next 30 years. Just imagine that within that next 30 years, there are more than 7 billion of people more. And how about the water supply? When we have more people, of course, the demand for the water supply will be triple. And this is somehow will be very worrying for us. We talk about the demand and we talk about the supply. And we talk about the water itself. It's very clear that in our Quran itself, it's been mentioned clearly that we have made every living thing out of water. So this is actually the stuff of life, meaning that every single life needs the water. And of course, from the science perspective, water itself is a life matter and also metric, mother and also medium, and there is no life without water. So this is very clear that the significant impact and also needed water to the human. And of course, when we talk about the water itself, factors that affect the demand for the water will be various. I talk about the population growth, and second will be on the industrialization and also the rural development, where the land use changes will somehow significantly affect the demand for the water supply. And of course, the water charges. When you are being put on a high price for water, for sure, you're not going to easily use the water. But in Malaysia, the water tariff can be considered as a very cheap. So that's a reason why we somehow didn't appreciate that much. And consumer preferences. As you can see that in certain countries, they have lack access to the water supply, and they really appreciate whatever they have in hand. And of course, the weather. This is something that we cannot control, but somehow the weather itself will significantly affect the amount of the water that are available, as well the quality of the water that will somehow end into our system. As water covers 70% of the Earth's surface, so it is rather that the planet Earth are known to be a blue planet, because the 70% of the surface is actually being covered by the water. And where the water is actually 70% of the surface area. As we can see also that, interestingly, science has proved that what was said 1400 years ago, as you can see here, by statistic, sea has been mentioned for more than 32 times in the Al-Quran itself, while the land 13 times. When we put into the proportions, when we put into the calculations, we can see that the percentage of the sea is actually 71%. Al-Quran already mentioned this 1400 years ago. And this proportion has led to the coverage of the more than 70% of the water. By definition, as we can see that, yes, it might look so huge. We might have many water supply and so on. But when we put into the proportions of the water that is actually available for the human consumption and so on, we are actually having less than 1% of the fresh water supply for our needs. The 97% of the water is actually sea, where you cannot directly drink from that because it contains high salt as well as some other pollutant. So by the amount of 7.7 billion of the people all around the world, the one that can actually cater the demand is around less than 1%. Even so, as you can see that the rest exists as a glacial ice as well as also in soil. So we need to exploit them. And of course, when we talk about the water, in most religious tradition, water is a basic to the physical and also spiritual life, symbolizing the purification, rebirth, and also the fertility. In Islam itself, as you can see that water is a symbol of life and also purifications. While, of course, in Buddhists, they seek the spiritual transformation, nirvana, in a natural setting, where the water itself plays a very important role in purifying the sins and so on. So do with the Christianity. As you can see that for Christians, baptisms by water, and itself is actually a symbol of the grace of God, signifies the spiritual rebirth in Christianity. And of course, Hinduism, as you can see that the Ganges River play a very important role and also symbol for the spiritual cleansing, where most of the Hindus believe that the Ganges River are actually having a cleansing power. So that's the reason why most of the Hindus will immerse in the Ganges River, and it's said to bring believers a purification and also freedom from sins. And when we talk about the interactions of the component in the environment, as you can see here, the water itself is not standalone. The interaction between the components of space in the environment is very important because it will stabilize the ecosystem to maintain and also to sustain the ecosystem in a good manner. And we can see that, it has been mentioned again in the Quran, that we have produced during everything in balance. So the interaction between the ecosystem, the hydrosphere, lithosphere, geosphere, atmosphere, and so on, is very important for us to sustain the ecosystem in a good order. And of course, as we can see that one of the very important aspects that we need to look into is about the controlling effect of the ecosystem itself. And there are various factors of the physical, chemical, and also biological. For example, sedimentation, ion exchange, water mixing, seawater intrusion, and so on, that will affect the quality of the water and also the availability of the water in the system. So the environment itself is a very dynamic and also complex. So it's not that easy as what you see, because when you go into a certain problem and so on, you cannot just ask the water what has actually happened to you. They cannot say anything. So as a scientist, we are dealing with a very complex and also dynamic ecosystem that we need to understand at the fullest of the process that will be responsible for the quality enhancement changes in the ecosystem. And of course, the anthropogenic activities is somehow one of the key factors that will determine the water pressure all around the world. As you can see that, the climate change, the physical alterations, the land use changes, and also the population is the key factor that contribute to the water pressure. By doing that, we need to also consider the ethical consideration. People are so greedy to have all things in hand, for example. They exploit all those natural resources without control. So where is our ethical consideration? So the way how we perceive environment and so on is very important in order for us to get the system in balance and so on. Not only that, the climate change is everywhere. Everybody talk about the climate change, except Donald Trump. He don't believe about the climate change. And of course, it will affect and also threaten the very existence of the mankind. We depend on the ecosystem to stabilize our life. And frequent and also abnormal rainfall pattern. We couldn't predict now when will be rain and so on. So it's very difficult for us to now to get the right pattern of it. Flood. It's a major flood event happen, as we heard before and so on. Droughts has become a phenomena, as well as the shortage of water supply everywhere. And, of course, that finally led to the water security problem throughout all around the world. And, of course, when we talk about the water security itself, it's all about the availability, access, and also the safe use of the water. It's not only about the quantity of the water that are available, but somehow the quality of the water that can be consumed by human. So those two factors are very important for us to always look into. Because in Malaysia, for example, we believe that we have enough water. Yes, in terms of the quantity, we have more than enough. But somehow when we talk about the quality, that are very serious problem that we are facing right now. And of course, when we talk about the emerging contaminants and also past and also new, in history, as we can see that there is something else that turned out to be the human activity. In the Roman Emperor era, you can see that the metallurgy and also the large-scale agriculture setting is creating air pollution during that era. They burn everything. And by that, the methane gas has been released and so on. And that is the first ever recorded cases on how the greenhouse gases are being released into the environment because of the anthropogenic activities. And the ancient Rome burned so much agricultural product during that era. And this is even more interesting, as you can see that the first emperor that unified China, Qin Shi Huang, he's actually the one who built the Great Wall of China. And he's being buried in the terracotta. If you ever visit that area, it's a very huge area. And as you can see that, it is reported died of ingesting mercury pills that believed to be intended to give him external life. Wrong advice. Why? Because during that time, mercury is very special. It's a metal, but in the form of the liquid. So only the emperor can have that. So it's a wrong advice by the doctors in the palace. And he still believed that. His tomb is being buried and also being channelized with all this mercury. And up to now, they didn't open the tomb, because it's full with the mercury. And that is actually the most polluted site in the world with the mercury. So this has become the first ever recorded of the toxicity case in the world on how the metals that can be benefit the human that finally will create death. And of course, when we talk about the industrial revolutions and so on, from 1.0 until 4.0, you can see that the first enactment was enacted in 1948 about the water pollution control and so on. Since the first industrial revolution and so on, people didn't talk much about the water pollutions and also the environmental pollutants. Only in 1948, they realized that the industrial revolution creates so much problem to the environment. And quite recently, in 2014, the European Union provided a new guideline that include the emerging contaminants in their drinking water guidelines. And of course, during that era, as you can see that more and more pollutants are being created and also introduced to the environment. And since then, the pollutions has increased over the years, and more pollutants are being introduced. Up to now, we can see that there are more than 40,000 of the chemical compounds that are available in the environment. But only 2,600 compounds are known to give an effect to the human. It's not that the other 32 are not giving any effect, but it's still understudied. We do not know what are the effects and so on. So I will give you some of the example of the pollutant that is actually we need it every day, but somehow end up to become a pollutant as a serious matter to our environment. And of course, we will look into the few examples in the industrial revolution, the Minamata incidents, because of the industrial release of the effluent into the coastal ecosystem and so on. And they only realized about the effect after 20 years of release those pollutants into the environment. The mercury transformed into the metal mercury, and it becoming toxic to the people in the Minamata Bay of Japan. Not only that, we also have the Ita-Ita incidents, as well as the black foot diseases because of the arsenic pollution in the groundwater of the Bangladesh. And when we talk about the effect of the pollutant to the human and also the exposure, we can see that those pollutants will create so many significant health impact to the human. We talk about the fertility, we talk about the reproductivity and so on. So those particular compounds will eventually affect the human ecosystem and also endocrine system. When we talk about the endocrine or new components of the pollutant in the environment, they can be classified into the natural pollutants as well as the synthetic estrogen. As we can see here that what we have in our body, most of the hormone and so on, can be considered as a natural one. That shouldn't be any problem. But the one that worries us is actually one that being synthesized because of the need of the human and so on. As you can see here that those products is actually being used every day by the human. And for example, we have so many pharmaceutical compounds that are available in the market. Surprisingly, those particular compounds, those particular active ingredient of the pharmaceutical and so on, is actually the one that we need every day. And we yet to come up with a best option for that particular pharmaceutical compound. And I believe that in this room, some of us may consume this particular medicine. Atenolol is being used for those who are having high blood pressure, while the ibuprofen are being used if you are having a high fever and so on, for example. That is active ingredient for the Panadol, for example. We use that every day. It's quite common. You can just buy that in the pharmacy and so on. But somehow, those particular compounds end up into our water system becoming as an emerging pollutant to the human. I will let you know later on about the effect and so on, and what we have found in our water supply, especially in Malaysia. Not only the pharmaceutical compound, but we also have other type of the disrupting compound in the environment that we use it every day. For example, the plasticizers, the water that you drink from the packed bottled water, for example, use bisphenol A as an active ingredient to create the plastic. We also have the antibiotics. We all use also the pesticide. Not only that, we also use the sunscreen and also lotion for our daily usage, for example. when you are too excited to get a whiter screen, for example, you will use krim pemutih kulit. You will buy from the internet, for example. You trust the testimony. You look into the artists, especially Korean, where they are so white, where they're having a glow skin and so on. I have my professor here, Professor Kim. So that is one of the particular pollutants that are available in the environment and up to become something that very dangerous to human. And of course, those particular pollutants end up into our water system through various processes and also pathway. And of course, based on that, in order for us to understand more about that, we need to have a very complete holistic research orientation. So my laboratory are looking to that, investigate the trend, pollutions, to identify the potential threat of the pollutants to the environment, to determine the environmental compliance, so-called we have so many guidelines and so on, and also to develop and also assess mitigation measure on how we could control those particular pollutants in the environment. And of course, the output of this particular research project and so on is hope to help the government to rectify the policy as well to update the public about the current situation of the condition in the environment. And of course, look so much into the environmental monitoring, environmental modeling, environmental risk assessment, treatment, and also mitigation, as well as the resource management. So when we talk about the environment, you could not only stand on your desired field. It must be a multidisciplinary approach. You need to talk to the others in order for you to understand better about the interactions in the environment. And of course, the approaches involve the life sciences, material sciences, environmental forensic, and many other fields. When we talk about the timeline of our research progress in my laboratory, the hydrochemistry laboratory, as you can see that I started to get involved with the water analysis in 2004 since my undergraduate project. And I came back in 2009, I established the hydrochemistry laboratory to focus more on the water issues and so on. Over the years, we evolved. The concentrations are more towards to the risk assessment and also the analytical method development, because we found out that there are more and more pollutants that are being introduced in the environment, and it becomes so difficult for us to determine it. We do not know what is actually we are dealing with. And when we ask certain laboratory and so on, they couldn't analyze it because they do not know what actually they are dealing with. And now, of course, I'm looking towards formal policy, rectification, and so on to improve the quality of our life. And of course, when we talk about the hydrochemical assessment and so on, it will involve 6 different steps from the very beginning to identify the problem that we are facing with until the result interpretation and also dissemination. And of course, it will involve so much about the quality control and also quality assurance. I always told my students that you are actually responsible to the public. If you want to become famous, create any statement that the public will become panic. For example, when you drink something, just put into your Twitter or Facebook that the water that you drink is actually containing radioactive. You will see that. You will get so many likes, so many retweets, so many reposts, and so on. So that's the way how. So in the environment, we are actually dealing with the public. You must be very responsible with the data that you provide. It must be very reliable and also provided with a strong, significant justification and also input. You cannot just simply tell. So that's the reason why when some of the researchers provided that the fish contain very high heavy metal and so on, so we couldn't eat that, the public become panic. And it will affect our economy as well. So you must be responsible for whatever information provided to the public. So those who are in the environmental field, we are actually the forefront of the public. And of course, the common problem in the hydrochemistry study, we are dealing with a very large set data and also complex as well, the dynamic ecosystem. It's not that easy. When you take 1 liter of the water, bring back to the laboratory, it's not just easy as you just immerse the probe and you'll get the data. You must understand the ecosystem as a whole. You cannot just see the water sample as a water sample. You must see the water as your life, and you need to understand it better than other people. With that, we use a fingerprinting technique in order for us to profile those pollutants that exist in our environment. most of the pollutant that exist in the environment is actually having their own characteristic. They carry their own DNA, they carry their own molecular structure, they carry their own information that you can get so many information from that. So from the environmental forensic approach, we use the fingerprinting techniques for us to get this information. We profile everything. And from that, we can actually know who is the culprit that actually contribute to those particular pollutants. In the environmental forensic approach, it's actually to bridge the gap of science and also the art of deduction. We cannot just stand alone by getting the water sample. We need to get those disciplines, for example, the identification, we need to also calculate the health risks, we need to also look into the policy on how this particular pollutant will affect the human health. Not only that, the information, the bridging the gap between all this information that we collected need to be put into one umbrella so that we can have more concrete justification and so on. And of course, in order for you to understand better about the environment, you couldn't only take the water sample, for example, and you analyze it. You need to also look into some different area that will tell you more about what is actually happening. And of course, it will involve the environmental exposure routes, the environmental forensic approach, as well as the laboratory scale study. And when we talk about the evolutions of the pollutant in the environment, as you can see here that the pollutants and also the way how we deal with the pollutants evolve over the years. If long time ago, we could only detect at a milligram per liter concentration. But now, with the evolutions of the instrumentation and so on, pollutions at the lowest nanogram per liter and also picogram per liter can be detected. And we are talking about something that are very ultra trace at concentration. And it doesn't mean that when we read the report 20 years ago, they didn't mention any about this particular pollutant, that it not exists. It's just because of that, during that time, those instruments couldn't detect to that particular lowest concentration. And that is the challenges for us. So that's the reason why we are developing a new method and so on, so that we can detect more pollutants at the lowest concentration. So we are using this particular approach from the method optimizations and also method development, sampling, sample preparation, sample extraction, as well as the instrumentation analysis. And of course, most of our method that we developed in our laboratory has become a pioneer research and has been referred by so many scientists all around the world. This is because in Malaysia, we are dealing with a very large and also complex environment, especially when we talk about the seawater and also in the estuarine ecosystem, because you are dealing with so much interferences in the ecosystem. So we developed the method and so on. So we developed the method for the biota detection, what we eat, for example, and so on, and we will determine those particular pollutants. We also developed a method of detection for endocrine disrupting compound in fish. And it's very surprising to see that many endocrine disrupting compound is actually being accumulated in our fish tissue. We also developed the method for the endocrine disrupting compound detection for water and also drinking water. And from our analysis, we found out that one of the most robust techniques and also instruments that are available to detect most of the compounds available in the environment are coming from the LC-MS. And as you can see here, the list provided here is actually less than 1% of the 40,000 chemical compounds that actually being synthesized in the world. So this is only the one that we know. So our knowledge about the particular compound are very limited now. And of course, the sources and the pathway for the contamination in the ecosystem, as you can see that quite before this, we only talk about this particular pollutant, dissolved oxygen and so on. If we read our report, our government report and so on, they will talk so much about the dissolved oxygen, the pH level, and then the E. coli, coliform, metal ion, and so on. That is not so worried for us as a water scientist, because most of our water treatment technology and so on are available to remediate that particular problem. But the one that worried us is actually the new pollutant that are invisible. How many of us are actually aware this is actually a pollutant to the environment? This is actually a microbeads used in your face scrubber. We use it every day. We believe that it will give us glow skins, we rejuvenate our skins and so on, but somehow it ends up as the pollutants to the environment. The microplastic contains so much of the chemical compound that will disturb the endocrine system of the particular human. This is okay because we can still see that. But the one that worrying us is actually the chemical compound being leached out from this particular materials. And of course, as you can see that the effluents, the radiation produced by the human manufacturing process and also the environmental process are actually the factors that are responsible on how those particular pollutants exist in the environment. And of course, it will end up into our drinking water supply and so on. So when those particular pollutants enter the environment, they will become persistent, they will accumulate in the different matrices of the environmental media. They are very anthropogenic because they are coming from our own daily usage and so on, as well as dispersion. They can disperse. And there is a record where some of the pollutant can eventually reach up to the Antarctic and also Arctic. So this is very interesting because once you create it, they cannot be easily removed from the environment. So our group analyzed some of the contaminants in the water cycles of the wastewater. And we have found out that certain pollutants actually exist in our water treatment system. For example, in most of the developing countries, the conventional treatment system is still taking place. We do not have money. As I mentioned earlier, one of the factors that create the water pressure is about the water tariff. If we change our water system, do we willing to pay more about it, for example? So we are still depending on the conventional water treatment system for us to remediate those particular pollutants. And we have found out that few pollutants exist in our water treatment system. But when we compare with more developed countries, of course, the concentration are still low compared to those particular countries. But somehow, the existing wastewater treatment system are not specifically designed for the complete removal of the EDC. Why? Because this EDC exists at a very low concentration. Most of the filtration system and so on are still not capable to remove that. I'm very sure that in every talk that I delivered and so on, the most hot question that people will ask, so what is the best brand that I should buy for my home water purification system? I have no answer for that. I'm also using that, but I couldn't tell that because they didn't pay me for the advert and so on. But somehow, believe me that we need that in order for us to minimize the risk and also impact. They couldn't guarantee that they will remove 100%. So this is why I always mention to most of my public engagement and so on, when they always ask about the question, if I drink the osmosis water, is it good? It's better that you drink the car battery water. Because it's the same. They remove everything, and it contains nothing. So what you will drink is actually a car battery water. It's even cheaper if you buy in the Petronas or Shell, rather than to buy the packed bottled water that will cost you RM1. And you just imagine that the water that being packed is actually more expensive than the oil itself. Why? 500 ml of the packed water will cost you around RM1, while the price of the 1 liter of oil will cost you around RM2 something. So better drink oil? Maybe. Okay. So that will be something that we need to look into. And of course, from our analysis with my colleague, we have found that certain pollutants exist in a various water body. This is because of our system are not being designed to properly manage those particular pollutants. And why this happen? Because in the system, the pollutants are being absorbed to those particular sediment, and those particular sediment will reside in the environment and will give some accumulative value to those particular pollutants. After some times, the concentration will be very high because over the years, over the time and so on, those particular pollutants will be accumulated. And one of the most important features that we need to look into is the sediment in the coastal ecosystem, because the Malaysia itself are being surrounded by the coastal area. And you can see that the coastal area is actually the sink for the various types of the chemical pollutions. most of the pollutions coming from the landward activity and so on will be absorbed, will be accumulated there. And as you all know that most of the pollutants, most of the activity of the aquaculture industry and so on are taking place in that particular area. And we talk about the process. As you can see that this is how the sedimentation will bring the pollutant into the environment. The absorption capacity and so on will bring so much of the capacity of the pollutants to the environment. And finally, those particular pollutants will be absorbed by plant, human, and also water. So this is the process that I mentioned earlier, the interaction between the geosphere, lithosphere, and also the hydrosphere on how certain pollutant can be transported from point A to another point. And for that, in order for us to understand better about the sedimentation transport and so on, we use our smart tunnel in order for us to understand about the mechanisms of the sedimentation transport and also how the pollutant can be transported into that particular area. Not only that, Langat River Basin is one of my favorite area. Yes, because even though when you Google about the Langat River Basin, you will find so many articles published in the Langat River Basin. But somehow, it's always interesting for us to always look into the Langat River Basin. There's always new story crafted from that particular area. When I first proposed to study about the pollution impact on the Langat River Basin, the panel rejected my proposal. Because why? He said that you can just Google and you found so many papers on the Langat River Basin. But I said to him that the pollution evolved, so do you. You are old now, and we need to know new information about the Langat River Basin. And they approved my first proposal on the Langat River Basin. And since that, I've been working about the Langat River Basin to study about the various contaminations and also processes that involve in the water river basin. As you know, that Langat cater for around 1.2 million people around, and it's actually a transboundary river basin that across few states and also supply for many people around it. And of course, from our heavy metal study, we found out that yes, it's a very low and also similar to those already reported in other localities, except for arsenic and also lead. And we understand that this particular metal is actually coming from the sand mining activity as well as the industrial activity in that particular area. And the Langat River area can be classified from unpolluted to the strongly polluted area, depending on the locality and also activity surrounds it, as well as the controlling factors. We found out that the Langat River Basin is actually a very complex environment because they involve so many land use changes and also other natural organic activities. Seawater intrusion, ion exchange, and so on is actually the one who control the process in the Langat River Basin. And interestingly, the new pollutants, for example, hormone pollutant and few others EDC, was observed in the sample. And we can see that higher hormone concentration being accumulated in the sediment compared to the surface water. I will show you the definitions of this nanogram and so on. Some of you might see that it's very small, very low concentration, so why you should worry about it. And of course, this work presented and also provide data on the concentration of the pollution and also magnitude, as well as the potential ecological risk and also contamination status of the river itself. Not only that, we also study and also profiling as many as metal that we could do, including the metal mercury. So this is something that's very interesting because as I mentioned earlier, Minamata incidence is because of the metal mercury pollution in the coastal area. So we like to do the same because we couldn't find any profiling data about the metal mercury in the coastal area of the Malaysia. So we do our sampling, we conducted our sampling from Perlis until Johor, and we tried to cover almost area in the Straits of Malacca. And what we have found that those particular pollutants are actually coming from the landward activity and up into our coastal environment and accumulate in our protein supply, which is fish. And from that, what we can classify, the northern area are having high concentrations of the pollutant, especially the mercury, and then followed by the southern area, and then the central area are having the less. But somehow, don't worry, the mercury concentration are still low, but don't eat so much. all those aquaculture products and so on. Okay? Because after my talk, then people will start thinking to become vegetarian and so on. Because there are so many things inside in our food. So what else we could drink to eat? I would say eat whatever you want. The most important things that you need to realize is to minimize the intake of those particular things. You couldn't say no. You still need to drink it, you still need to eat it, but somehow try to minimize. So from that, anthropogenic activity generated from the multi-classes endocrine disrupting compound, pharmaceuticals, hormone, pesticides, and also pesticides were detected in the Langat River. You know that hormones are coming from the human body. How it can be end up into the river system? This is because we have all those synthetic compounds that are available in our market. So for example, when we do our analysis, the risk assessment survey, and also calculations in our Langat River Basin, we have found out that for certain compounds, especially the pesticide, it provided a very high risk to the ecosystem and so on. It might be very low, but somehow, after a certain time and so on, it will becoming a very high risk to the ecosystem itself. And of course, we can see that the pharmaceutical occurrence in the samples and so on are quite recently detected in the water, and this becoming a pioneer data. The highest concentration of pharmaceutical compound were detected in the Gombak River, one of the most polluted river in Malaysia. And as you can see that clarifications concentration were observed in all of the samples. And while ecotoxicological risk assessment have found out that there is a moderate reach of the risk in that particular environment. When we say about the moderate, it's already an alarming state that we need to consider the mitigation measure in order for us to make sure that the risks are very low. Not only that, we also focus so much on the Klang River estuary because this is one of the most busiest commercial port in the Peninsula Malaysia, and the habitat for the various commercial seafood products such as fish, clam, mollusk, and also cockle. So this is one of the very important economic region in Malaysia. And of course, not only that, we also study about the groundwater. As you know that in Malaysia itself, we have more than 5 trillion cubic meter groundwater reserve. But somehow, we are still using less than 10% of the freshwater supply throughout the Malaysia. And as you can see in the map, the states that heavily use the groundwater for their water supply and so on are in the Kelantan, Terengganu, Pahang, Sabah, and also Sarawak. They heavily depends on the groundwater as their water supply. One of the most very interesting case study that we have in our research work is about the Kelantan Basin. As you can see that Kelantan use for more than 70% of their water supply coming from the groundwater. And from that, we can see that the land use changes, the land clearing and so on, is significantly affect the water quality in the Kelantan itself. So when you pollute the river, and now you pollute the groundwater, so what else left for you? Okay, so from our analysis, we have found out that the Kelantan basin is actually being polluted with the nitrate pollutions because of the agricultural activity and so on. Over then 8 years, as you can see that from 2014 to 2018, the changes of the nitrate is quite fluctuated because of the land clearing and also the agricultural activities are taking place in that area. And from our modeling and also prediction exercise, we have found out that the nitrate concentration will be increasing in the 2030 because of the agricultural activity are being practiced in the Kelantan Basin. And we also conducted study in certain small islands. We have Professor Datuk Mazlin here, one of the pioneer researcher in the small island. So we study about the impact of the groundwater abstraction and well-known Sipadan Island, Sabah. And from that, we understand about the ecosystem, how this particular island is very fragile. As you can see, it's a very small island that do not have any surface water and so on. So people and also visitors in that particular island depending so much on the groundwater for their water supply. So if you are visiting a small island, any island all around Malaysia, you are actually a culprit to that particular problem. Because why? You are using the groundwater. So we need to keep pumping the groundwater reservoir to provide you enough water for your activity and so on. So what is the problem? So when you keep pumping the groundwater without control in that particular fragile island, you are actually creating more problem, especially the seawater intrusion, the microbial pollutions, and also, for example, the mineralizations. So when the seawater start to mitigate into the freshwater system, they will change the chemistry of the water itself. So this has become a very significant problem to most of our small island in Malaysia. And from that, as you can see, that these are several findings of our research group. We did some modeling study to see on how the freshwater and also seawater mitigate into the aquifer system by using the 3D model. And we also conducted the one-dimensional study to see what are the chemistry changes when the seawater and also freshwater are mixed together. And we also have the groundwater chemistry phases in order for us to evaluate the trend of the changes. As you can see that in this particular slide, the water becoming very saline after years of attraction. And we also look into how the groundwater level are affected because of uncontrolled pumping activity in this particular area. So now, more interesting thing that we need to look into from ecosystem to human. As we know that ocean through the product, marine organism and so on, is an additional and also crucial routes of the human exposure to the endocrine disrupting compound. Because we need to eat fish and so on, for example, for our protein supply. And eventually, those particular fish, for example, can accumulate most of the pollutants that are available in the system, for example. And what we have found, EDC can be accumulated in the fish tissue, in the bones, in the liver, and also the organ system of the fish itself. And we did some study of the most famous aquacultured fish in Malaysia, ikan merah, ikan siakap, dan juga ikan bawal emas. And we have found some significant concentrations of the endocrine disrupting compound in this particular fish. But don't worry, please eat that. I'm afraid that if the press will come and say that, or Prof. Zaharin said it's very dangerous for us to eat all those things. This particular aquacultured fish is having a very high commercial value, and it's very expensive. Okay? But somehow, those pollutants are still in a very safe limit. I mentioned earlier, things that we need to look into and also incorporate in our information is about the risk questions and also risk hazard provided by this particular intake, for example. You can still have that, but not more than 1 kilogram a day, for example. It depending on your body mass and so on. So that's the reason why don't worry so much. When there is a water supplier coming to your house, you are actually drinking a very polluted water and so on, blah, 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 and you feel afraid of it, and you buy. And up, you buy of those system. Ask them, what is the risk quotient if I drink every day, 1 liter, 2 liter, and so on. So those information is very important for us to disseminate to the public. And of course, we did also some study in the sea catfish, big-eye croaker, and we also found certain pollutants, for example, the endocrine disrupting compound, hormone, plasticizers, and so on, are quite high in our fish sample. The most striking value are actually coming from the bisphenol. The bisphenol A is actually a plasticizer, the active compound that make plastic, for example. So that's the reason why the Ministry of Science, Technology, and also the Environment, and the new Minister, Mastak, are looking for combating the plastic problem and so on, because they can actually produce and also releasing some of the BPA into our environment. We also found the diclofenac concentration in our samples. So diclofenac is actually used to treat pain and also inflammatory diseases such as gout. If you have gout, you eat so many fish, aquaculture product and so on, you'll be consuming this particular medicine, and you're creating another problem. And of course, in the mangrove snail, we also found out some of this particular hormone, progesterone. So what happened if they consume more hormone? I'll let you know later. So this is some of our findings. We profiled the area, and we found out there is a various concentration over the area and also time. And again, when we calculate the risk assumptions and so on, the risk assessment for this particular edible biota is still at low risk, safe to be consumed. Don't worry. And of course, as you can see here, we also did some study to profile in detail. As you know that the fish will eat the daphnid and the daphnid will eat algae. So we look into the complete food web in order for us to understand better on how those particular protein will be transported from point A to B and also C and end up into the human body. And of course, one of the most important aspects that we need to look into and also always to put in mind is about the sustainable development goal. And the focus of this particular talk, as you can see, that is to look into the clean water and also sanitation. And we have so many things to be covered under this particular SDG agenda. One of it is the quality of the water that can be delivered to the human. And of course, we cannot run away from it because we need to drink the water. And also, tap water is actually the additional route of the human exposure to the health risks associated by this particular exposure. And as you can see that the exposure of those particular pollutants can be various, end up into the human body because we are the one who will drink these particular pollutants. And of course, those particular pollutants can be entered into our body through different routes of way, through inhalations, direct exposure, ingestions, and also dermal contact. So those are actually the routes of exposure of those particular pollutants in the environment. And as you can see that the most common pollutant that we talked about before is on the inorganic chemical and so on. And the World Health Organization revealed that the WHO guideline is actually inadequate based on the current list provided. So they have a very limited numbers of pollutants to be monitored. For example, in Malaysia, we have around 32 compulsory parameters to be monitored in our water drinking supply exercises. But in the European Union, they have more than 346 compound elements to be monitored in their drinking water supply. And of course, these are the list of the Malaysian water quality standard. And as you can see that none are actually addressing the endocrine disrupting compound to be addressed in our water supply. So there's a need actually for us to look into the important aspect of the inclusions of the endocrine disrupting compound in our new water guideline. And of course, we also did some study by comparing the bottled water that are available in the market. Are they really giving some benefit effect to human or not? So from that, we did some calculation. I couldn't reveal the brand, but somehow don't depend so much on the packed bottled water for your daily usage, because there are certain issues that now I think it's becoming a very hot debate, especially about the pollutions of those particular compounds and so on. But more importantly, it's actually because of the compound being released into our packed bottled water, because those bottles are crafted by the plastic, and certain plastic can actually releasing some of the chemical compound that are actually very dangerous to human. So when people say that, don't drink the water directly, but it's safe, it's clean, and so on. Yes, it looks clean, but there is some invisible threat that could be posed to the human. And we educate people through different and also media social, and it's very surprisingly to see that some of us still believe that this particular triangular logo to shows the number of recyclable usage, for example. If it's a number 1, then you can only use once and so on. But that is actually not. It shows you the chemical compound being used to synthesize and also create this plastic. So be careful. Whenever you want to buy something, not only to look into the price tag, but also to look into the chemical content in those particular product that you're going to buy. And of course, something in the water, scientists have found out that the drugs finding their way into our drinking water supply, and these particular drugs will somehow affect the system because it's still unknown risk perception. As I mentioned, there are more than 40,000 of the chemical compound available, and then they give some adverse impact, and also knowledge are still very limited. And there is inadequate water treatment plan to solve this problem. From our survey and also monitoring study, we have found out that in certain areas, especially in most of the developed countries, this particular endocrine disrupting compound are very high because of those activity and so on. So these are the area, and as you can see that the WHO indicate that the WHO guideline is unwarranted, to address the issue of the pharmaceutical level and also exposure. So I hope that the government of Malaysia will pick this particular issue and will revise some of this water quality guideline to include this particular pollutant. And as you can see that in certain area, the monitoring study are still left behind, and not many countries are actually very well addressing this particular issue. As I mentioned, for us to analyze this particular compound, it will take some time, costs, and so on. It will involve a very sophisticated instrument as well, manpower, and some other hidden costs and so on. So this is some of the record of the chemical of emerging concern in Malaysia. Selangor River, Langat River, Peninsula Malaysia, and also some of the sediment. And we are still leaking behind it. And you can see that surface water is commonly used as a drinking water. So that's the reason why we need to look into this first and also to serve the database in order for us to come up with the right rectifications for our water guideline. And of course, the effect to the ecosystem is various. The long-term effect and also the common mixture is actually more toxic. And as you can see that the regulatory effort should be required and also to provide some of the rectification for our current policy and also guideline. And the risk perception is the potential mitigating the problem. And the drinking water treatment plant is actually the last security step before we will consume the water. So in other words, that this particular drinking water treatment particular system is actually very important for us to remediate the problem. And what we have found in our water drinking treatment is this one. The chemistry oral of the contraceptive pill. Pil hormone ataupun pil perancang keluarga. It can be easily purchased in the pharmacy. And of course, if you want to become a transgender, if you want to have a glow skin, for example, please consume this particular contraceptive pill. It will change not only your skin, but also your sexual preference. And we found out that this particular active ingredients of this contraceptive pill end up into our drinking water supply. What happened? So the birth control giving the rise of the transgender fish. From our survey and so on, we have found out that in certain species of fish and also mollusks, they're becoming transgender. They have two genitalia, and they are not attracted to the opposite sex. They're becoming gay. They're becoming lesbian because of this particular pharmaceuticals end up into our ecosystem. As you can see here that the limit regulated by the European Commission is only 0.03 nanogram per liter. And at level of 4 nanogram per liter, they can give a sexual preference changes to this biota at 4 nanogram per liter. How could we imagine the concentrations of 4 nanogram per liter? So just imagine that at 1 nanogram per liter is equivalent to 1 part per trillion. So how many is 1 nanogram per liter? 1 nanogram per liter is equivalent to 1 drop of water in 20 Olympic size of swimming pool. And you can just imagine that at 1 nanogram per liter, they can give a sexual preferences changes to this particular biota. Very, very small concentration. And the challenges here is to detect to this particular low concentration. Not all laboratory, not all instruments are capable to analyze this. From that, we have come up with a review on the effect of this particular contraceptive pill to the biota. Kesian. Most of the fish and so on are the ones who receive the effect. And how they work. They attack the nuclear receptors of the cell. For example, when the body hormones, of course, this is the mechanisms of the biochemistry and so on. You can see that when the body hormones enter into the mechanisms, the receptor will specifically choose the right hormone for them to work with. But somehow, when there is an endocrine disrupting compound that will mimic the natural hormone, they will taking place, the process, and finally will disturb the endocrine system of our body. And that is what happened. They will affect the cell, tissues, organ system, and the body as a whole. And this is the problem that we're facing right now. So that's the reason why somehow the cancer cases and so on are quite common right now. because of this particular effect. For that, we do our survey. We conducted our survey in the Putrajaya to look into the intake of the water supply, the drinking water and so on, and also the way how the people of the Putrajaya perceive about the drinking water in their area. And from that, we analyzed this particular compound coming from the pharmaceutical, plasticizers, pesticide, and also hormone. And this particular pesticide is actually the most common used by the people in Malaysia. From the statistic department, they provided that Malaysians are heavily stressed. So most of them consuming the high blood pressure medication. So end up, they're becoming a very high concentration in our water system. So this is what we have found. The highest value is actually the caffeine. As you know that, I do not know whether Malaysians love coffee so much, because it end up, the caffeine concentration in our water supply is very high. But the caffeine is actually a stimulant drugs used to stabilize your mood and so on. When you stress, they will induce you with this particular compound. And so do with other pollutants in the environment. And it becoming some of the anthropogenic matter. So we know that where actually they are coming from and how they behave in the environment. And of course, as you can see, that is a common industrial additive, the bisphenol A. As I mentioned earlier, bisphenol A is actually a plasticizers. And it's becoming a very concern nowadays because the concentrations are quite high in our water supply. And from that, we calculate the risk quotients for this particular pollutants. And we provided with some aspect of the level of risk posed by this particular pollutant to our drinking water supply and so on. From that, we specifically calculate what are the right amount that you should drink and so on, and how you should mitigate if you're having some problem of the water supply in your area. And from the human health perspective, all EDC have no potential risk, even though the risk quotient is less than 1. But it doesn't mean that you can be very happy now. It still exists, but as I mentioned, we need to come up with the right mitigation measure in order for us to reduce the extent of the pollution to the environment. For that, we come up with a few methodology for the treatment efficiency and also to provide the cost effectiveness of the material that could remediate this problem. And as you can see, that one of the problems that we're having now is because most of our water treatment supply system is actually very old, and they can only cater to remediate those heavy metals and also suspended solid, for example. And they are inefficient because those pollutants exist at a very low concentration at a nanogram per liter. And of course, the byproduct from the industrial activity and so on will create more problem to the particular water system. And of course, as I mentioned earlier, the surface water and so on are becoming drinking water supply sources for Malaysians, especially. And for that, we come up with the low-cost absorbent, natural absorbent, and also environmentally absorbent to remediate this particular problem. And as I mentioned earlier, there are no any particular product that could promise you that they could remove all this particular pollutant in your water supply. No, don't believe them. Okay? Especially some of us spend for almost 20,000 just for a water purification system at home that could provide you with the alkali water, for example, and so on. That couldn't solve any problem because they can only remove certain heavy metal as well as suspended solids. And we come out with certain material that could remediate that, and it's proven to be some of very significant and also valuable material that could solve certain of our problem. And one of our products has caught attention by the 13 country medias and also across continents by using a very simple and also cheap material. This is actually a waste product coming from the crab shell. We modified and also enhanced the capacity of the crab shell, and it's proven to remediate certain of the pollutants in our drinking water supply. And we also use basket clamp that could absorb the cadmium metals in our water. Not only that, we also use the chicken egg from our own variety, Akaputra, proven to remove up to the 90% of the heavy metal in our water supply. We also use natural bioremediation techniques to absorb certain pollutant in our water supply. Currently, we are working on a new material to remove certain endocrine disrupting compound in our water supply. And those particular material is actually coming from our Kenaf product, where those particular Kenaf product is very, somehow having a very good potential to becoming a fiber and so on that could remove most of the pollutants that we studied before. And, for example, the hormone of estrogen in the water can be removed up to 99%. So finally, what we can drink afterwards is a very safe and also safe to human consuming and so on. As I mentioned before, the challenges that we are dealing now is not at a milligram per liter concentration. It's at a nanogram per liter concentration. So in order for us to come out with the material and so on, it must be very comprehensive, very sophisticated, that could remove at the lowest concentration. So for that, what we need to do next is to come up with a risk perception to make people more understand about what we are dealing with, and also to talk more about these particular things and so on. Educations to the public and so on are very important, because we drink that for the long-term effect and so on. Humans are exposed to the EDC, and we analyzed SWOT analysis, and we have come out about the effective dissemination way to tell the public, and then we need to engage the public actively, and then a better understanding of the nature and also extent of the EDC in the water supply and so on. And from that, in order for us to have more comprehensive study, especially about the water supply and so on, there's supposed to be future conditions of the estimation and so prediction. We must involve the modeling aspect. And we need to study upscaling the studies to the basin scale. We cannot just only study one river. We need to study about the basin scale itself. And then preventing assurance factor from causing the future contaminations, trace occurrence, and so on. And of course, as I mentioned before, this can reduce the extent of the pollutant exposure, and then public could have sustainable access to the good water supply. Risk management and also monitoring framework for pharmaceutical and drinking water supply, supporting the multivariate approach in drinking water supply system, monitoring and also management for safe water resources. So meaning that the approach that we need to look here is a multivariate approach, not to only look into one single aspect, but the different view of it must be also addressed. So started from the risk assessment and so on, then we can have a better view about the future risks and so on. So risk communication and also the governance is very important. So it's not only one-way communication. It's not anymore about the top-down instruction, but the government, for example, the policymakers and so on, need to listen from the public. So it must be a bottom-up approach. When the public tell that we want a good water supply, then the government need to listen and to come up with more interesting way of handling that. So we believe that the communication must be two approaches, from top-down and also from bottom-up. With that, I would like to also acknowledge the sponsors for most of my studies here. The UPM, the Ministry of Education, Ministry of Science, and also IERC from Korea. And then the Kurita, TWAS, and also Syarahan for providing the financial support to make all this thing happen, and also to help me to provide some of these particular findings and sharing basis with you all today. And also, I would like to acknowledge my family members, my parents, my wife, of course, my daughter, who couldn't be with us today. She wants to listen, but I'm afraid that she will be the one who will perform in the stage afterwards. And of course, to all of my former deans, Associate Professor Dr. Ramzani, and also Professor Dr. Mat Nasir Samsudin, as well as some of my mentors and also colleagues who contribute effortlessly to my success today. I'm here because of all the support from my friends and also colleagues, as well as my knowledge gatekeeper. They are here today, scattered around. So thank you to all of my students and also ex-students for your support and so on. And of course, staff of the Faculty of Environmental Studies, especially the lab staff in the Department of Environmental Sciences, who helped me a lot. I saw Encik Zaharin, Encik Ghaffar, Encik Zubir here, that helped me a lot, surviving all those lab analysis and so on. And I have my colleagues here, Timbalan Dekan, all those management team and so on. And of course, I couldn't say anything, but again, I would like to thank you with the support and so on. With that, thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Yang Bahagia Prof. Dr. Ahmad Zaharin Aris for the outstanding presentation. Can we give another round of applause? I think it is very obvious that water is very important. At least for people that are not doing research in water like me, that's the take-home message that I'll take. I think there are lots of advices given by Prof. Zaharin. But don't take all of the advices, especially the ones that the transgender pill. So don't take it. Yeah? If there's no water, then there will be no life in the earth. However, due to various causes, as what we mentioned during his presentation, then waters are being contaminated, and it is actually our role in order to make this world as a better world. I would like to take this opportunity to congratulate again Prof. Ahmad Zaharin and his team for securing substantial research funds, and he has shown to us in, I think, last few slides, the sponsors that have helped him and his research, and that what makes him today. And thanks again, everybody, for being with us today. Inshallah, I hope that we can meet again in the next forthcoming series of inaugural lecture. Congratulations again to Yang Bahagia Professor Dr. Ahmad Zaharin Aris for the presentation and the success in completion of your inaugural lecture. And I hope that this will become or will inspire also the rest of academics in UPM and in other universities to be as successful as what he has become. Thank you very much all. Assalamualaikum warahmatullahi ta'ala wabarakatuh, and have a nice day.
Thank you Yang Berbahagia Profesor Dr. Muhammad Iqbal Saripan in chairing the event, and thank you Yang Berbahagia Profesor Dr. Ahmad Zaharin Aris for the lecture delivered just now. Ladies and gentlemen, that marks the end of this inaugural lecture event. On behalf of the organizing committee, I would like to extend our gratitude to Yang Berbahagia Professor Technologist Dr. Muhammad Iqbal Saripan for his willingness to chair this event today. I will also like to extend our thanks to all the audience for attending this event. With that, I would like to invite Yang Berbahagia Professor Technologist Dr. Muhammad Iqbal Saripan and the audience to have a photography session and then enjoy your lunch that we have prepared for you this afternoon. Thank you and have a nice day. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera.